Flipped classroom video for Maths AS Unit 1, solving quadratics by completing the square. So, solving quadratic equations. When we have a coefficient of x squared equal to 1, if we have x squared plus 12x plus 24 equals 0, for example, then the first thing we can do is just take away 24 from both sides. And the point of that is, it leaves us with just an x squared plus 12x, so just an x squared term and an x term on the left hand side, and we can just complete the square on that bit. So that's what we do. So remember, we half the coefficient of x, so the 12 becomes a 6, so that's x plus 6 squared, take away 6 squared, which is the completed square form, equals minus 24. We can now add the 6 squared to both sides, and of course 6 squared is 36, which gives us x plus 6 squared equals minus 24 plus 36, which is 12. We can now square root both sides, so we have x plus 6 equals plus or minus the square root of 12, and because 12 is 2 squared times 3, then we can take the 2 squared out of the square root, whereupon it becomes just a 2 because it needs to be square rooted. So that gives us plus or minus 2 root 3. And we can then subtract 6 from both sides, leaving us with x equals minus 6 plus 2 root 3, or minus 6 minus 2 root 3. Okay, what if the coefficient of x squared is not equal to 1? Well, we know how to do this theoretically, but let's have a go at this one. First of all, we take away 1. Again, like the previous one, we want just the x squared and the x term, so we've got 3x squared minus 7x equals minus 1. We now divide by 3, and this is slightly different from doing it without it being part of an equation, because we won't have to bother forming brackets because we can divide through the whole thing by 3. That gives us x squared minus 7 over 3x equals minus 1 over 3. We now complete the square, so half of 7 over 3 is of course going to be 7 over 6. We just times the bottom by 2. So that gives us x minus 7 over 6 all squared. Take away 7 over 6 squared equals minus a third. And we recognise that 7 over 6 squared is in fact 49 over 36, and so we also add that to both sides, so we have x minus 7 over 6 all squared is minus a third plus that 49 over 36. 1/3 is 12 over 36, so we're going to have minus 12 over 36 plus 49 over 36, which gives us 37 over 36. We can then square root, and we have x minus 7 over 6 equals plus or minus root 37 over 6. And finally we add the 7 over 6 and get x equals 7 over 6 plus or minus the square root of 37 over 6. And notice, for the first example on this page, I've written both solutions, and very often in exam question type situations they will ask you to write both solutions, but it's not always necessary, because in a way you have written both solutions, or I have, on the right hand side by saying 7 over 6 plus or minus root 37 over 6. Okay, so some benefits of completing the square. I mentioned graph sketching previously. We've solved x squared plus 12x plus 24 equals 0 using the completing the square method. And now we're going to think of it in terms of functions. So if we define f of x equal to x squared plus 12x plus 24, what we've done is we've solved f of x equals 0. But an alternative method would be to complete the square for f of x and then set it to 0. So this would give us the following. F of x equals x plus 6 squared minus 12. And for f of x to be equal to 0, that tells us that x plus 6 all squared minus 12 has to equal 0, and that leads to f of x equals 0, implying that x is equal to minus 6 plus or minus 2 root 3. Okay, so that's just showing where equations 1, 2 and 3 come from, because we're going to be using them in a minute. Now similarly, for the 3x squared minus 7x plus 1 equals 0, 1, we would end up with the first equation would be stating that g of x is 3x squared minus 7x plus 1. The method of completing the square would give us 3 times x minus 7 over 6 squared minus 37 over 12. And notice we didn't see that form in the solution of the quadratic before. And that was because, as I mentioned, when we divide by 3, when we have the equals minus 1 as it was in that case, then we don't have to bother bracketing it. If we had bracketed it, that's what it would have looked like. And the fact that g of x is 0 tells us that x is 7 over 6 plus or minus root 37 over 6, which is our third equation. So you can look at them in relation to what we've just done in terms of solving them being equal to 0, but we don't have to make things equal to 0 to get those values. We can get them from the completing the square as shown on here. But anyway, this way of looking at a quadratic function allows us to sketch it relatively easily. So first of all, we have our equation of the function that we're looking at. Then we have the completed square form of it, and then we have the answers which come quite easily from the completed square form. And now this is what they look like. And how do we know this is what they look like? Well, I know because I put it on GeoGebra. I put the x squared plus 12x plus 24 and the other one on, and there it was. But I'm going to show you how you can sketch them, but this is going to illustrate it. First of all, we know from that top equation for the green that f of 0 is 24, because the x squared and the 12x disappear in that case, and that means we can write on the axis there, on the y-axis, that the green graph must cut the y-axis at 24. For g of x, we have g of x equals 3x squared minus 7x plus 1, and therefore if we put 0 in, we're going to get 1, which means the red graph cuts it at 1. The next piece of information is that, and this is very important, because the completed square form of x plus 6 squared minus 12 is there, the way we can minimize that is the minus 12 is fixed. We can't change that. So the only thing we can change is the x plus 6 squared. And we know that with real numbers, the smallest value of a square is 0. And the way we get that is to put minus 6 in there. So if x is minus 6, we would have minus 6 plus 6 is 0. And when we square it, it's still 0. So that tells us what the minimum for this quadratic is. So there's another method for finding the minimum. But it also tells us that that point there that's identified, it has to be minus 6 minus 12. For g of x, we can see that x has to be 7 over 6, and that then the y value would be minus 37 over 12. So that gives us our minimum points. The next bit of information is, of course, the solution, but what it means is we don't actually have to work out what minus 6 plus or minus 2 root 3 is. We can just say that it must be 2 root 3 to the left, or minusing it, or 2 root 3 to the right, or plussing it, of the minus 6. So that also sort of illustrates the symmetry of the situation, and in fact the line of symmetry for this graph would be x equals minus 6. For the red one, same sort of job. We have the plus or minus root 37 over 6, and we can see that that's either side of the minimum for that graph. Okay, so how would that actually work if you were doing this? Well, you'd get your three equations by completing the square and then seeing what the answer was for the f of x equals 0. But then you could follow these steps. First of all, you could just draw a curve. Now, the black blobs are there just to help me draw this accurately, as it were, but you don't need to. You can just draw a curve. So imagine the black dots aren't there, we've just drawn a green curve. Now, the first thing we can do is that because f of x, when we complete the square, can be written as x plus 6 squared minus 12, this is a very neat way of finding out the value of the minimum, because the minus 12 is fixed, so the x plus 6 squared is the only thing we can vary, and of course for real numbers the smallest value of x plus 6 squared is 0, because the smallest value of any square is 0. In order to get 0, we need x to be minus 6. So that tells us that x is minus 6 will give us the minimum. That gives us a y value of minus 12, and we can write that as a label next to the minimum point for this quadratic. The next thing we can do is we can write the x-axis, or y equals 0, because we know now that the minimum has a value of minus 12, and so the x-axis must be above that. The next thing we can do is, well, we know that we have this adding and subtracting this to root 3. Roughly that is 3.5, so we can add 3.5 to minus 6 to get minus 2.5, and we can subtract 3.5 from minus 6 to get minus 9.5. So that gives you the values rounded off for the intercepts there, or the roots. The next thing we can do is, because we have minus 6 and then we in fact have minus 2.5 for that root there, that tells us that the y-axis must be to the right of it. So we can draw the y-axis in, and then finally we know that if we put 0 into f of x, which is the value of x we need to find what the y-axis intercept is, that gives us 24 for that. So you can see how from the completing the square, the equations that come out of that, we can very easily sketch a curve. For the other one, we can just go through that same process. So first of all, we recognize that to minimize this g of x, we'd have to put x is 7 over 6 in to make that square 0. So that gives us our minimum point there. So 7 over 6 is about 1.2, and minus 37 over 12 is about minus 3.1. That means we can say where the x-axis is. The solution of the 7 over 6 plus or minus root 37 over 6 allows us to say that the roots will be just over 1.01 either side of our 1.2, so that gives us 2.2 or 0.2. The fact that we've got 0.2, which is greater than 0, tells us that the y-axis is slightly to the left of that, and then the original equation with x equals to 0 put in gives us 1 for the y-axis intercept. So that gives us a way of graph sketching using completing the square.